So your warm-up says to solve by completing the square. How do we solve by completing the square?
Square the x, or square the b solution.
Yeah, we're going to do something with the b, but before we do that, what are we going to do?
It's 7 on the other side.
Yeah, you want to get the 7 on the other side. So let's add 7. I'm going to leave a blank. Remember, we need a space because we're going to add something to both sides. So it's going to look like this. And then, yeah, Eric said we got to square something with the b term. That's right. But before you square it, what do you have to do? Divide by 2. So what is 4 divided by 2? 2. And then what's 2 squared? 4. So we're going to add 4 to the left. That'll make it factor into a perfect square binomial. If you add it to the left, you also have to add it to the right. So after this step, what would I have on the right? Yeah, x plus 2 squared. The whole point of adding that 4 was so that it would factor in this way. And then we have an 11 on this side. Yeah, you want to take the square root of both sides? So this would be x plus 2 equals plus or minus the square root of 11. And then what's the last step? Subtract 2. Good. So x equals negative 2 plus or minus the square root of 11. What are your questions on this?
Why'd you add a plus 4 before the equal sign?
The whole point of adding this plus 4 was so that it would factor in this way. So anytime you're completing the square, you take the b term, you divide it by 2. That gave us 2. And then you square it and you add that to both sides. The whole point is so that it factors in this way. It's called completing the square. So you complete this trinomial by adding something that would make it a square. It's the whole trick. Any other questions? Remember, if you don't like completing the square, we're actually learning the alternative to completing the square today. It is called the quadratic formula. This is section 5-6. We are doing 5-7 on Wednesday, 5-8 on Thursday, homework check Friday, review Monday, test next Tuesday. Alright, so today we're talking about the quadratic formula. The quadratic formula only works when you're in standard form. So you have to get your x squared term in front, then your x term, then your constant. Determine what A, B, and C are, and then plug them into this formula. I'm sure you've heard people sing it. You just heard a little girl sing it. But it is negative B plus or minus the square root of B squared minus 4AC all over 2A. So as you guys saw in the video we just watched, if the directions just say solve, you get to pick the method. So the methods are you could factor, you could complete the square, technically you could graph if you wanted to. I don't know many students that prefer graphing. Or you could use the quadratic formula. The quadratic formula is great because it always works. Whether it's factorable or not, it's going to work. Alright, so I know some students that just go right to the quadratic formula because it's kind of the foolproof method. You don't have to mess around with the multiply, add stuff. You just plug it in. So this is the quadratic formula, right? What goes in our B spot? Negative 9. What's going to go in the A spot? 1. What's going to go in the C spot? 5. Basically all you're doing is plugging it in. So everywhere where I see a B, I'm going to put a negative 9, as you can see on the board. Everywhere where I see an A, I'm going to go ahead and put a 1. And everywhere where I see a C, I'm going to put in a 5. So after you do all your plugging in, it should look like this. Then basically you just simplify. So negative 9 is going to be positive 9. Inside your square root, you square negative 9, you get 81. Negative 4 times 1 times 5 is negative 20. And then 2 times 1 on the bottom is 2. Continue simplifying with that subtraction. You get 61. Double check to see if there are perfect square factors here. Or like if you want to do a factor tree. I can't think of any helpful way to break down 61. So I think we're good here. What are your questions? Here's number 2. So again, if the directions did not say to use the quadratic formula, you could try to factor. Your multiply number would be -5, your add number would be 3. Nothing's coming to mind at the moment, so I could move on to completing the square. But look, if you are trying to complete the square, you'd have to divide everything by 5. That's going to give you some messy fractions pretty much throughout the entire problem. So the quadratic formula seems like our best option here. So here's the quadratic formula. Notice that all of the variables are in parentheses. That will help you keep your signs straight, especially with this negative b part and with this squared part. Sometimes if you put a negative number and you square it, if you don't keep it in parentheses, you'll forget that a negative times a negative is a positive. So just make sure you keep in the parentheses as you go here. What are all the b's going to turn into? 3. What are all the c's going to turn into?
Negative.
What are all the a's going to turn into? 5. So I'm just going to go through and rewrite it. So I'll have -3 plus or minus the square root of 3 squared minus 4 times 5 times -1 all over 2 times 5. So in the front we just have -3 plus or minus 3 squared gives us 9. And then we have -4 times 5 times -1. That's going to be minus -20 or plus 20 over 10. And then you can just do the addition inside the square root. Again, try a factor tree. Nothing's going to work here. So we are good to go. What are your questions? All right, here's number 3. Again, you could mess around with completing the square or factoring. But the directions say use the quadratic formula, so I'm not even going to mess with the other ones. What do all the b's turn into? 2. The a's? -1. And the c's? 4. So I have -2 plus or minus the square root of 2 squared minus 4 times -1 times 4 all over 2 times -1. Questions so far? This next part is just simplifying. So -2 plus or minus 2 squared is going to give us 4 plus 16 because you have a negative and a negative. -2 on the bottom. So inside our square root now we have a 20. What is special about 20? Yeah, you can break the 20 down. So if you did a factor tree, you could do 2 and 10, 2 and 5. So what's going to come out front? A 2, and what's going to stay inside the square root?
5.
A 5, good.
Can you cancel the -2?
Very good. So they all have 2's in them, right? So you can simplify. Now let me point something out. These 2 were both -2's. And then here you have a positive and a negative, so you don't really need to worry about your signs so much here because it's basically like turning the plus into a minus and the minus into a plus, so you still have both of them plus or minus. So if they're all negative, just go ahead and cancel the negative out. So this is just 1 plus or minus the square root of 5. Technically, you could have -1 plus or minus the square root of 5 all over -1, but that's just kind of wasting your ink. What are your questions on this one? Here's number 4. Again, we start with the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. All the b's turn into negative 6. All the a's turn into 1. All the c's turn into 9. Good. So we end up with negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 9 all over 2 times 1. Negative 6 is positive 6. Inside the square root, we will have 36 minus 36 all over 2. Now, I want to point something out to you guys. What are we going to get inside the square root? A 0. Anytime you get a 0 inside the square root, you are adding 0, then you're subtracting 0. Does that do anything? No. So whenever you have a 0 inside the square root, you're only going to have one solution because you can't add something, you can't subtract something. So you basically just get whatever you had out front, the negative b over 2a. Does negative b over 2a sound familiar to anyone? Yeah, this is the vertex of the parabola, right? So if you graph this parabola, the vertex would be at x equals 3. And remember, solutions are where it touches the x-axis, so it would look something like this. So this part of the quadratic formula right here, the square root of the b squared minus 4ac, that's called the discriminant. When the discriminant equals 0, you only have one solution. And that's because the vertex of the parabola falls on the x-axis. Any questions on that? You guys might have noticed all the ones we did previously, we got a positive number as our discriminant, and we had two solutions. We had the plus solution and we had the minus solution. When the discriminant is 0, you only have one solution. It's because the vertex falls on the x-axis. Questions so far? Now, if you look at the directions, I haven't been focusing too much on the directions. I've just been jumping right in. But here it says we'll have one real solution. So what do you think we're going to get in our discriminant? A 0. Okay, I'm assuming that's how that's going to work out. But let's go ahead and do it. So we'll have negative b plus or minus the square root of b squared minus 4ac all over 2a. Replace all your b's with a 4. Replace all your a's with a 1. Replace all your c's with a 4. So negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 4 all over 2 times 1. This is going to be negative 4 plus or minus 4 squared is 16. 4 times 1 times 4 is also 16 all over 2. What do we get in our discriminant? It's exactly what we thought. We got a 0. So your solution here is just negative 4 over 2, which is negative 2. Again, that's the x value of the vertex. Anytime you only have one solution, it's because the vertex falls on the x-axis. If the vertex is not on the x-axis, you either have two solutions when it crosses the x-axis, or you'll have no real solutions, and that's kind of like when your whole parabola is above or below the x-axis. What are your questions on this one? Here's another one. Again, directions say we'll have one real solution, so I'm assuming we're going to get a 0 in our discriminant, but let's go ahead and work through it. So I'm going to replace the b with a 10, so I have negative 10 plus or minus the square root of 10 squared minus 4 times 1 times 25 all over 2. So we have negative 10 plus or minus the square root of 100 minus 100 over 2. What's my vertex? Or sorry, what's my solution?
0.
The discriminant 0, which means your solution is just your negative b part over your 2a part, which is the vertex. So we're coming up with negative 5. What are your questions? So you can see in the directions that it says we're going to get two imaginary solutions. What do you think we're going to have to get inside of the square root to have an imaginary solution? A negative number. Okay, so the first few we looked at, we had a positive number inside this discriminant. That gave us two real solutions. When you had a 0 as your discriminant, you had one solution. Here we're going to have two imaginary solutions because we're going to get a negative inside your discriminant. And remember, the discriminant is the b squared minus 4ac part. All right, before we can do anything, though, we have to get this into standard form. So you want to move the negative 10 over by adding 10 to both sides. Once we've done that, we can go ahead and set up the quadratic formula. All of our b's are going to turn into negative 6's. So I start with a negative 6, plus or minus the square root of negative 6 squared minus 4. My a is going to turn into a 1, and my c is going to turn into a 10. All over 2 times 1. All right, let's do some simplifying. So negative 6 is 6. Plus or minus the square root, negative 36 squared. Oh, I totally just gave it away. Negative 6 squared is 36. Minus 40, because 4 times 1 times 10. All over 2. So what do I get in the square root? Negative 4. Do you guys remember what the square root of negative 4 is? 2i. So right now I have 6 plus or minus 2i over 2. What would the last step be here? Simplify. Everything's divisible by 2. So we can go ahead and turn this into 3 plus or minus I. So they're saying that there are two imaginary solutions. One of them would be 3 plus I. One of them would be 3 minus I. And again, that happens anytime you get a negative as your discriminant. The discriminant is this part right here, the part under the square root. What are your questions on this? All right, here's number 8. Again, we got to get it in the right form. So I added the x and I added the 1. That equals 0. Here's my quadratic formula. A is 1, B is 1, and C is 1. So just basically replace everything with a 1. So we have negative 1 plus or minus the square root of 1 minus 4 all over 2. Inside the square root, you will get a negative 3. The square root of negative 3, we can't simplify the 3 part, but we can take care of the negative part. Remember, a negative under the square root just makes it an I. So we have negative 1 plus or minus I times the square root of 3 all over 2. That's all we can do with this one. Nothing simplifies. So we are good to go. What are your questions? All right, again, directions say we'll have two imaginary solutions, so I'm assuming our discriminant will be negative. But let's work through it just in case. We have negative 2 in the front, plus or minus the square root of negative 2 squared, minus 4 times 1 times 3, all over 2 times 1. Any questions? I'm kind of breezing through this, just plugging in part. That's the easy part. Simplifying is not too bad, too. Negative is a positive 2, plus or minus 4, minus 12, all over 2. We're going to get negative square root of 8. Do you guys remember how the negative square root 8 will simplify? I think we did it a couple times last week. If you forgot, you can do a factor tree. 2 and 4. 4 goes into 2 and 2. 2 square root of 2 would be how it would if it was just 8, it'd be 2 square root of 2, but the negative, you got to put an I in there. So we'd have 2 plus or minus 2, because you had 2 2's in your factor tree. I because you had a negative sign, and then you have a leftover 2 that stays in the radical. All over 2. Those 2's are obviously going to simplify. What 2 does not simplify, though? Don't get, like, simplify crazy in here. Yeah, the one inside the square root doesn't simplify. Remember, you can't multiply or divide numbers from outside a radical to a number inside a radical. So we end up with 1 plus or minus I times the square root of 2. Questions on this? Here's your homework, 17 to 55, odd. Make sure you're paying attention to what you're getting in the discriminant and then making sure that your answer kind of matches up. If you get a positive in your discriminant, 2 real solutions, 0, 1 real solution, negative, you only have imaginary solutions. Don't forget, homework check on Friday.